Hey, hello everybody. I'm going to go over with you the balancing equations and nuclear reactions test review paper. So let's go over this. We'll have our test on Wednesday. And we'll make sure everything's in focus here for you. So the particle emitted in an alpha, beta, or gamma radiation. Well, in alpha radiation, that's going to be a helium nucleus, which we represent with the symbol He. The mass is 4, and there's 2 protons. This is the atomic number. This tells you the atomic mass of the elements. The beta particle, what's emitted, is going to be an electron, because in a beta decay you have a neutron changing into an electron and a proton. So the symbol we usually use for this is that, showing that its mass is 0 and it has a -1 charge. It's not showing what its atomic number is. And then for gamma radiation, the particle is the gamma ray, and that looks like the Greek letter gamma, which looks like a kind of a stylized Y. So which symbol is used for the alpha beta particle? Well, for the alpha particle, again, it's going to be He, 4 with a 2, and that's alpha. Kind of looks like a fancy A. And then with the beta particle, the symbol is written like that, and that's an electron, 0 mass, and a negative charge. And then for a gamma ray, it's a fancy looking Y, which is in the Greek letter gamma. What is the charge in the atomic mass when an atom emits an alpha particle or a beta particle? So the change in atomic mass. Well, for an alpha particle, you are emitting a helium nucleus. So what you're going to do is the atomic mass decreases by 4 in whatever starting atom you have, and the atomic number will decrease by 2. That's when you have an alpha particle. So that's what you're looking for there. When a beta reaction occurs, what's going to happen is, so let's see, beta, you're going to be emitting an electron with no mass and a negative charge. So what's going to happen is, in whatever element you start with, the atomic mass is no change. It stays the same. Okay, same, I guess I should say the same. The atomic number will increase by 1. That's supposed to be atomic number increases by 1. So what happens is, if you start off with the element carbon and it goes through a beta decay, it's going to change into the element nitrogen, because that's the next one on the periodic table. There'll be no change in mass. List in order the penetrating abilities of the radioactive particles from the greatest to the least penetrating. Gamma radiation will go through cement, concrete. It takes very thick cement, concrete, lead to stop it. So gamma, concrete, lead. And let's see, the next most penetrating is going to be the beta particle, which is basically just the electron. And it will, you'll need aluminum foil or cardboard will stop it. And then the least penetrating of all is going to be the alpha particle. And the alpha particle, it's kind of big. Something like a paper will stop it. Number 5. What is the charge on an alpha particle, a beta particle, and a gamma ray? Well, let's see. For the alpha particle, we've got this, 2, 4. Okay, the charge on it, there is no overall, well, it's a helium nucleus, so its charge would be, we've got 2 protons, but no electrons, so its charge will be a +2 charge overall, because it's just the nucleus. It doesn't have its 2 electrons normally around it. Beta particle is an electron, which charge is -1. And a gamma ray has no charge. It's just high energy. What material is necessary to stop a gamma ray, alpha ray, or... Okay, well, I answered those over there. So to stop an alpha particle, a piece of paper. A beta particle, you're going to need something a little thicker like cardboard. B-O-A-R-D. Maybe aluminum foil, if you'd like to. And then a gamma ray, you're going to need concrete lead, and very thick. What particle decomposes to produce an electron of beta radiation? Well, it's going to be a neutron. So you get a neutron that, with a neutral charge, it'll break down into an electron with no mass and a charge -1. And it will also form a proton that has a mass of 1 and a plus charge. And this is what changes our elements when we have beta decay into a new element. We're gaining a proton. And that's the definition of the atomic number. It's how many protons you have. Let me slide this up. What particle is needed to complete this nuclear reaction? So what we've had happen here is we've had beta decay here. So let's take a look. The atomic masses need to be the same. So since we started here with 10, and now this is showing that we're adding a neutron over here. So the masses need to add up to 11. And so over here we have 11 minus 4 because we have the helium nucleus. When I look on the periodic table, atomic number 11 is sodium. So this would be element Na. Oh, wait a minute. Did that wrong.